Hello, N4H and H here, and the inspiration of this video is my friend Joel, KC4WZB. He thought that I should do a video on the subject of decibels and gain, and S meters and things like that. So that's why you see a big S meter there. This is the Yaesu FTDX 5000 MP that I typically use here as a base station. And so we're going to use it as an example to discuss decibels and S meters. So first of all, what is a decibel? It's a measurement scale that we use, not unlike there's watts, there's volts, there's amps, right? And decibels is a way that we measure signal increases, strength increases for volts and watts, if you want to put it in simplistic terms. Their volts and watts are treated a little bit different, but we won't get into that. I want to try to keep this video short as possible and also focus more toward those who might be new to the hobby. So decibel means tenth of a bell. So you guys know that volts, we call volts volts because of a gentleman named Mr. Voltaire. Microfarads for capacitors from Michael Faraday. I did say microfarad. Sometimes I mess up and say Michael Farad. So Michael Faraday. Then we have, the megacycles is what we used to call frequency. Cycles, kilocycles, megacycles. And then in honor of Heinrich Hertz, who did a lot of research and scientific discovery related to frequency, radio frequency, we, some decades ago, adopted the term Hertz for a measure of frequency. So you hear megahertz, kilohertz instead of megacycles. Old radios, by the way, you guys out there with some vintage rigs know what I mean. You've got old radio dials, no LEDs, okay, and their dials were actually in megacycles, MC, not megahertz. So decibel, guess who that's named after? You might have guessed it, Alexander Graham Bell. And they were going to measure, just like with capacitors, we measure in farads, but then again, capacitances are usually a fraction of a farad, so that's why we have picofarad, microfarad, and things like that. Well, in the case of bells, we measure it in tenths of a bell, decibels. So let's look at this S meter and talk about decibels. You see how the numbers are not all evenly spaced? That's because, I'll just say, there's a word called logarithmic. Logarithmic is different than linear. Linear is you can start at a point, end at a point, draw a straight line between the two. It's linear. Logarithmic does not follow such a pattern. So the scales are, it's different. Okay, it doesn't follow a linear pattern. So these meters, it's a tough thing for the manufacturers to try to get this perfectly accurate by spacing those little lines out, anticipating how that needle is going to move. That's it's called a D'Arsonval movement. That's a real needle with a little spring in there. And in my background working with radios since the 1970s, I can tell you that with a D'Arsonval movement, you generally calibrate it in the middle, which in this case will be S9, and they won't be perfectly accurate on the low end and the high end. So you calibrate in the middle, and you would expect it to be a little bit off on the low end and high end. And it just has to do with the meter movement. But the manufacturers will move those little tick marks around there, the S1, and there's a dash for the S2, and then there's a S3, another dash for S4, and then S5. They'll move those around to try to get it close, but it won't always be perfect. And furthermore, they don't always use the same scale to calibrate these. And what I mean by that is the International Amateur Radio Union, IARU, established decades ago a chart. I'm going to move the camera over here and show you my other screen for a second on my computer here. There's the IARU chart, so it shows you what an S unit should represent. So if you were measuring the signal strength coming in at the receiver negative 121, look down there at the bottom left, S1 is negative 121 decibels over a milliwatt. That's what that M means. It's just a relative term there. It's also 200 nanovolts or negative 14 decibels over a microvolt. So the magic number I want you to look at is in the middle here. I'm going to try to get it in the center of the screen. 50 microvolts, negative 73 dBm, S9. And you'll hear a lot of people argue about S meters because they're not all set to where S9 equals negative 73 dBm or 50 microvolts. It's a point of controversy because the manufacturers all vary in how they do it. They don't all follow this chart exactly. But again, what I was pointing out is, let me get back over here and look at this S meter. Even if you did attempt to follow that chart perfectly, it means you've got to try to move those little hash marks around, run a lot of tests, and, and here you're dealing with a mechanical movement in this case to try to get that meter to really track that chart exactly. That's a little bit of a chore. And in all honesty, these S meters are relative. You just got to look at them as relative, and this is why a lot of people base what they'll tell you when they tell you 5.9, it just means they heard every word and you're full quieting. For example, got a little bit of hiss in your signal, we might call that an S7 or an S8. So, and a little more scratchiness will degrade that scale. For example, my friends doing soda with the QRP rigs that have no S meter at all, they go by ear. You could literally be not even, moving my S meter on this radio here, and I can make you sound like you're a 599 because of all the filtering I can do. So I could literally say, well, you're 599. Heard it. You're perfectly readable. I'm not looking at my S meter, but it sure does sound like a 9. And then, tone on that last number is a tone quality. So it really is kind of a relative term when we talk about S meters because it can vary from radio to radio. So I might tell somebody you're S7, but on the next person they're talking to, maybe you're receiving him at the exact same strength, but on their radio it's an S8. So we'll talk about this. I'll pick on Yaesu, for example, with this particular radio. I know what the calibration procedure is for this one, so we'll talk about how we use this one as an example of how S meters vary. So the calibration procedure on this radio is to tune it to 14.2 megahertz, and you use a signal generator and you inject, like that chart over there would say, you would inject 50 microvolts. It's technically 50.1, okay? Or negative 73 dBm, and if I were going to calibrate this to the IARU standard, I would then set the radios to where the needle goes to the 9. Yaesu didn't do that. So let's go through what this radio, how it's calibrated. I'm going to move over here to my iPad. I've jotted some notes down. So we'll zoom out a little bit. So there's the IARU standard on the left. S1 equals negative 121 dBm or negative 14 dB UV. We'll just stick with dBm to make this simple. Well, look on the right's the FTDX 5000, and it does happen to be calibrated to where S1 equals negative 121 dBm, so we're all good there. But according to the IARU, an S5 should be negative 97 dBm. Now, let me explain. The less negative is positive. It's a good thing. By going less negative, you're showing a stronger signal. So S5 is negative 97 dBm. Look at the FTDX 5000. To get an S5, you've got to get all the way up to negative 83 dBm. You've got to beat that 97 by 14 dB. So you could really honestly call my radio stingy, especially between S1 and S5. Now, S9, negative 73 dBm. The FTDX 5000 produces an S9 with negative 71. So technically, if you're an S9 on my meter, you're technically 2 dB over S9. Think of it that way. So on the left, again, is the ideal S6 dB per S unit, but that varies from every radio, not just manufacturer to manufacturer, but even radio to radio. So let's look at the dB per S unit on the FTDX 5000. from S1 to S5 is actually 10 dB of difference. Now the reason I'm looking at the calibration instructions for the radio and the amount of signal they're having you inject as you set it, and it would equal 2.5 dB per S unit to go from S1 to S5. Interesting though, look at there, from S5 to S9 it's 3 dB per S unit. Again, now look, IARU wants us to do 6 dB per S unit. This radio, 3 dB per S unit from S5 to S9. Now once you get to S9 plus 10, negative 63 dBm is the industry standard, or IARU standard. On the FTDX 5000, you have to hit it with negative 61 dBm. So again, back to that 2 dB. So anything above S9, I can add 2 dB to it and give somebody a fairly accurate S meter reading. Now, let's talk about how all this relates to your everyday operating of your radio. And I'm going to get back to that chart there in a minute. So let's say you've got a dipole antenna, and you're talking to me, and I've got you at S1. Now, let me quick review here from your tests. Remember the isotropic antenna and my discussion on antenna gain and dBi versus dBd. That was a previous video. So dBi is a measurement you'll see that is how much gain does this antenna have over what we call the imaginary isotropic antenna, which is essentially an antenna that puts out equal power in all directions, literally spherical. And so the dipole, our basic antenna, if you hovered in a helicopter above my dipole and looked straight down, the pattern of a tuned dipole on one band, just so to be technically accurate here, because it changes with multi-band dipoles, but a dipole tune for one band will typically have a figure-8 pattern coming off the broad side of the wire. So the ends of the wire are where your weakest signal is. That's why you'll hear of people putting up 2 dipoles for the same band, but putting them perpendicular to one another. And by the way, that's a fun discussion. You can play around with something called diversity. You can have an electrically rotatable receive antenna, but that's another discussion. So figure 8, what does that figure 8 mean? It means that you've taken some signals, and I mentioned this in my video that I did a few weeks ago about how an antenna develops gain, the one with the balloon in the picture. To develop gain, you're taking away signal from some other direction. So in the case of the dipole, you're taking signal that would have gone toward the ends of the antenna, and you're shifting it to the broadside in a figure 8 pattern. That represents 2.15 dB over an isotropic antenna, 2.15 dBi. So now, with that as a point of reference, let's say you're talking to me with a dipole and you're S1 on this meter here. Now let's say you switch over to a beam antenna. Let's say you homebrewed your own Yagi, and your estimation is, and you've designed it to produce a 10 dB gain, and let's say indeed it does. On my radio, since it's moving in 2.5 dB per S unit increments, you would go from an S1 to an S5 because it's 10 dB between my radio S1 and S5. And remember, after S5, it's 3 dB per S unit. Let's say you went out and redesigned your antenna, and you came back and you said, hey, okay, I was S5 before. What am I now? I've gotten a 3 dB gain. I've got 3 dB more designed into my antenna. You would move on my radio from S5 to S6. Now again, the IARU standard, you would move from S5 to S5.5 because they say 6 dB per S unit. You got to get to know your meter, right? So in my case, your 3 dB that you added to your antenna gets you from S5 to S6 on this radio. So that's an example of how it relates to antenna gain. Now let's talk about amplifiers. That's a very interesting discussion, especially if you're new to the hobby and you're thinking, oh yeah, okay, everybody tells me I need to get a linear amplifier. Okay, well it is a good thing to have. Let's put that into perspective. So you remember the magic number 3 dB. 3 dB is good. Sometimes it's bad. So for example, let's say 100 feet of coax has a 3 dB loss. You just lost half your power. But let's say you go from you've got a 100 watt radio. Well, let's take this FTDX 5000. It can do 200 watts. But let's say I've got it turned down to 100 watts. And let's say you've got an S7 on me. And I go from 100 to 200 watts. Now that's 3 dB, double, 3 dB. So 2 times 100, 200 watts. And let's say you say, hey, you are now S7.5. That means you've got a perfectly calibrated S meter, by the way, because 3 dB gain, if the S meter is perfect, then at 6 dB per S unit, then I just gained a half a S unit. Now let's say I turn on my amplifier and I set it down to say 400 watts. So I just doubled again from 200 to 400, another 3 dB. On your S meter that's perfect, I go now from S7 to S8. Now I want to get to S9. What have I got to do? I need another 3 dB. So another 3 dB means I double my power. So now I'm going to double from 400 watts to 800 watts. And now I get S8.5 on your perfect meter. So I've gone from S7 to S8.5 by increasing from 100 watts to 800 watts. Now I want to get to that S9, right? What do I have to do? Another 3 dB. I got to double it again, and I got to get to 1600 watts, which is of course 100 watts past what our legal limit is, to get to that magic S9. Again, assuming your meter is actually calibrated perfectly to that IARU scale. Again, most radios are not. As you can see on this one, it's not even the same up and down. I mean, from S1 to S5, it's 2.5 dB per S unit, and from S5 to S9, it's 3 dB per S unit. And above S9, well, the scale is off by 2. So let's say that I'm talking to somebody on 75 meters, and they've got a 20 over on me. So the meter is, let me zoom in. The meter is deflecting at plus 20. Here we go. Let's just say, let me find somebody. See if there's anybody strong on there I can use as a example. Okay, so see that guy's he was hitting the 10 over 9.
Man, I can hear you in there.
And look at that guy. He's pushing.
Noise. I can't really make out what you're saying.
Right, he bumped 30. Now again, on my radio, that's 32, right? But look, at that point, it's the fluctuation in their voice makes that hard to really discern.
I'm really.
Pretend now I'm putting a 20 dB over S9 signal on you at 800 watts. And I go ahead and cheat a little bit, and I double my power to 1600 watts. If you were reading a 20 on me, it's just going to move up a little bit more above that 20 by 3 dB. Not even to the next tick. That's 30, see? So that's not a whole lot for what you go through to get from 800 watts to 1600 watts, even 100 watts above legal limit. Now, I'll put that in perspective for you. When you get much above 800 watts, it gets very expensive to have an amplifier. So, for example, I've got an AL80B over here. It's not lit up, but I'll pan over there to it. It's kind of dark in here right now because I wanted you to see that meter. I'm going to brighten it up. That is an Ameritron AL80B. It can produce a kilowatt if you really stretch it out, right, with one tube. I don't do that generally unless I'm trying to break a pile up. I will generally run it at about 700 or 800 watts. And the reason is, as you saw a while ago when I kind of went over that with you, to get from S7 to S8.5, I can do it with 800 watts. To get from 8.5 to 9, I got to have another 800 watts on top of that 800 watts. So you can kind of see that it's a little bit of a diminishing return there. Well, and to do that, amplifiers that can produce that level of power require 240 volts. So if your house doesn't already have 240 volts run to your ham shack, you'll have to have that done. I've done it. I've got a Elecraft KPA 1500 up here that'll do legal limit, and that's the subject of a previous video, so I won't go any further on that one. But I've actually done some tests where I said, hey, look at your meter. What have you got on me right now? Oh, you're 20 over 9. and I went from 800 watts to legal limit, and I moved, and this was a guy with a, he was using a flex radio, which literally reads it out in decibels, in decibel increments. He said, okay, you're 23 over 9, which is about right. So I went from an S9 plus 20 to an S9 plus 23 because I went from 800 watts to 1500 watts. So roughly 3 dB increase. So if you want to spend the extra and have that extra oomph, you can. But I will tell you, and a lot of folks would agree with this, that first 500 or 600 watts is what makes all the difference in the world. And there are plenty of amplifiers out there that won't break the bank, that can produce easily 600 to 800 watts for a fraction of what it costs to get the legal limit. So for you guys who might be new to the hobby and hearing about linear amplifiers and worried about the cost and the return on your investment, well, if you want to start off with something, 600 or 800 watts should do the trick. Because look, the meters are not all totally calibrated anyway. And I'm going to close it with this. I'm going to find some CW. Oh, there's W1AW sending their code practice. Now I'm going to turn IPO off. So there's their real meter reading. There, that's their real meter reading. But remember, my meter is off, so I can add. They're hitting about S9, so they're probably 2 dB over S9, right? Because of what we just talked about. Now with CW, and this is going to give me the opportunity to explain the last thing I wanted to get into, which is automatic gain control. These S meters, most modern radios, in the past it was different, but most modern radios, the S meter taps off of the automatic gain control circuits. That's way down in the receiver from the front end. And so it's just a voltage they extract from the automatic gain control and use it to drive that meter. So everything you do upstream in the receiver to cut signal strength can affect the S meter. And this is why you've seen in my past videos, I'm always talking about, go for signal to noise ratio. So I'll give you an example by using this CW signal right here. I actually want to find a weaker one. Well, let's try the 40 meter band. Well, he's not all that weak either. Oh, there's one. He's barely moving the meter, look at that. Okay, now I'm going to turn off all the DSP help that I've got going on over here on the right. I'm not going to pan over there. You've seen that in my previous videos. Well, now look at him. He's actually hitting up about S6 on this radio, which is stingy, remember? Well, watch what's going to happen to his signal. This is why I've always said, forget the S meter, go for signal to noise ratio. And why I'm going to use this as an example, even though we're talking about S meters and decibels. I'm going to turn on digital noise reduction, which already helps. I'm going to pan a little bit over this area here so you can see that I'm on a 600 hertz crystal filter. I can, whoops, hit the VFO. I'm going to switch over to a 300 crystal filter. You see how that took a little more noise out compared to that? Okay, now this radio has also some digital filtering that can take it from 300 down to 50, and I'm going to engage that. Now watch the S meter. As a matter of fact, even on a mechanical filter it may drop some, but when I kick in the digital and I go down to 50 hertz bandwidth, knocks the S meter way down. Again, because I'm doing things up in the front end of the receiver that are affecting the automatic gain control circuit later in the radio, and it's driving the S meter. So you can't get too hung up about the S meter anyway. Go for the signal to noise ratio. Now with this Yagi rig, what I've done is I've turned on digital noise reduction and it's set at maximum. I've engaged. I'll go ahead and pan over here for those of you who might not have watched my earlier videos. I'm in this section of the radio here, the DSP, and I've got, this is digital noise reduction. There's that 50 hertz filter. I could widen it out and I get a little more noise, and then but the S meter will come up too. But again, I'm going for how clean it sounds, and now I'm going to kick in the audio peak filter, APF. Listen to the difference. It's the icing on the cake. The last remnant of noise disappears. Now look at the S meter. He started out up there around S5, S6. So you can't really get too hung up about an S meter anyway. And again, this is why my soda friends would call that a 599. I mean, we'd say, well, I'm hearing everything you're sending. You sound like an S9 to me because I'm not hearing a lot of noise in there, and your tone's great. So, but look, when I turn all this back off again, he's pushing S7. Now one other thing here, I'm going to take off amp 1. Again, right now I'm giving as accurate an S meter reading as I can. And if somebody asks me for an S meter reading, I go to amp 1 because that's where it's calibrated. Remember, the radio is calibrated at 14.2 megahertz with amp 1 engaged. On other radios, other brands, they may not call it the same. You'll have like no preamp on, but they'll calibrate with preamp on. I'm going to go to IPO, which is essentially on our Yagi radio. It means I'm turning off my RF preamplifier. I'm disabling the first stage of amplification in this receiver. Why? On these lower bands, I really don't need all that sensitivity. Now look what that did to the S meter. So I'm going to go back to default. Look. Listen to the noise though. See, it knocks more noise down than it does him. Yes, his signal dropped, but I hear him better over the noise. And see, now I'm going to kick in the DSP. That's just digital noise reduction. Now the 50 hertz filter, I'll even widen it to 100. And the audio peak filter for icing on the cake. Not moving the meter, sounds like a 599 to me. So that's why you can't get too hung up on an S meter. So even when you think about back to the linear amplifier, that first 500 or 600 watts, it adds a lot of punch to your audio. Forget what the S meter does. It's what it does for your audio, your intelligibility. It really does make a lot of difference. Going from even 700-800 watts to legal limit, they're not going to notice much difference in your audio. And if they've got a meter that can register in 3 dB or 1 dB increments, they're going to see it move 3 dB. If it's an accurate meter. So there we are, decibels, gain, amplification, S meters, and how screwy they can be. But listen to that, like a code practice oscillator in here, but S meter looks terrible. If I shot the video and sent it to that guy, he'd go, man, I wasn't coming in very good. Well, listen how clear you are compared to. Okay, you can get the S meter to go up higher, but listen to all the noise that comes in. And there we go now. So I hope that gives you some perspective here on gain, decibels, S meters, and I hope you enjoyed the video. I want to thank my Patreons for helping out to keep the channel alive. www.patreon.com/N4HNH if you want to help. Thanks a lot. 73 from N4HNH.